Hello everybody, welcome back to the UNICAT channel. Today I would like to speak about how to manufacture a body for an expedition vehicle. So what we want is a shelter to live in that is strong enough to withstand the forces which come up when you're driving off-road. It should be well insulated. It should be protected against impacts like stones or branches. And not to forget, it should also be lightweight. And it's not only about the outside, you should also look how it looks inside, because if you have walls where you can already attach furniture, then you have a big advantage when it comes to the interior work. The first and probably most important question is, what material should be used to build the body? There is a variety of common materials, for example steel, aluminium, fiberglass, carbon fiber, even aramid, and some people prefer to build a body from wood. The cheapest option is definitely to build a body from steel, making a steel tube, framework, and plank it with sheet metal. The planking can be done by welding, by riveting, or by gluing. What you have to look after is that you do a good paint job for all the metal parts, otherwise you will have corrosion all over the place. Many military shelters are built this way or have been built this way in the old days. Even my first expedition vehicle, a Unimog with an ambulance shelter, was built that way, and I had constantly to work on it to keep that body in shape. Another often used material is aluminium. Aluminium weighs approximately only 1/3 of steel, but it's not so strong, so you have to do a slightly thicker wall thickness, and also the tubing has to be a little bit stronger. So you save about 40% of weight compared to a steel body. But you still have the same problems, not corrosion problems, but you have the problem of insulation. If you have a tube structure, then you first of all have to do something on the inside. You have to add some insulation material. And still, where you have the framework, the insulation is very bad. Some people prefer to build a body for an expedition vehicle from wood, which is a great material. But I personally don't have experience with building a body from wood, and it never really attracted me. So 30 years back, when I had some experience with my first expedition vehicle with a steel body, and I was not happy with the weight of the rig, I looked into sandwich compound panels. Sandwich compound panels consist of the outer layer, the inner layer, and the core. The core can be honeycomb, it can be polyurethane foam, it can be PVC foam, or any other foam that meets your technical requirements. Mostly polyurethane foam is used because it's firm, it has a very good insulation, and if you choose the right material, it does not absorb any water. So let's talk a bit about the layers. The layers are also called FRP, fiber reinforced polymer. And this FRP is a composite made of a matrix, which is the liquid stuff in the beginning, which can be polyester or epoxy, and the fibers. Actually, the fibers can be glass fiber, carbon fiber, aramid, and they are embedded into the matrix. And the matrix doesn't do anything but gluing the fibers together. That means that the strength of the panel only comes from the fibers, not from the matrix itself. So this type of FRP layers are readily available. You can buy rolls of it, or you can buy the complete composite panel. And you can choose the wall thickness, and often you can also choose what's inside the layer. And that's very important. First of all, the question is what type of fiber is there inside? And then the question is how is it arranged? So for example, with this structure you see here, you can see that this is a woven fiber net, yeah? And there is also other fiber inside which is just tangled. But very important is how much fiber is in this layer, you know. I mean, there is a lot of matrix and maybe a little bit of fiber, or there is enough matrix to glue the fibers together, but the rest is only fiber. And of course, as only the fiber gives you the strength of the panel, you should look for a product that has a high content of fiber into the layer. And that's not all the same. So some people sell panels or sheet material that has a very low content of like 20–30% of fiber only, and the rest is matrix, which is only weight without any advantage. And others go up to 60–70% percentage of fiber in the panel. So you should look what you are buying, because that makes the panel stronger or not. So here we have a piece of sandwich compound panel which is made with layers from fiberglass and polyester. So that's a standard product which we are using for most of our bodies. And this one here is a panel which is made of carbon fiber. You see it by the color. Carbon is black, while fiberglass is not white, but this has some white paint in it to make it white. But both materials are super strong, super durable, and much lighter than if you would build a steel body or a body out of steel. So for example, when you build a body with a steel frame and sheet metal, you should expect like 22 kilos per square meter. If you do it in aluminium, which is 3 times lighter, but you need more material, you go down to almost half of it, let's say like 11–12 kilogram per square meter, while a square meter of this fiberglass panel is 11 kilo, and this carbon panel is about 7 kilo. So you see that there isn't a big weight difference between an aluminium body and a fiberglass body. But with a fiberglass body, you don't have the problems of insulation. You have a proper wall inside to fix your furniture. And it's the same material everywhere. It's easy to bond with other panels. So there are quite a few other advantages over aluminium for this fiberglass panel. Now, when it comes to impact or repair, then there are pros and cons. Normally people say, okay, I have a metal structure, everybody can repair it. Yes, but if you hit an aluminium panel, with a hammer. I don't have one here, and I actually don't want to do it. You have a dent in it, and it will be very difficult to get the dent out. I mean, if you roll the truck, the dent can be very big, and the whole structure of the body is gone. Now, if you have a fiberglass panel, and the carbon is even stronger, so you have to do a lot before you can really hurt it. But if you hurt it, I do it with the corner here, okay, then your impact is just only here. So if you have a hole like this, you fill it with glue and it's done. Or in the beginning, you put a piece of tape over it, and probably this stays for years because it just works until you have a good chance to repair it and get some paint on it. Okay, I was just asked to make the same thing with the carbon, and I mean, you see, it's much stronger. It doesn't even really go through. So the same hit on the carbon fiber has less impact than on the fiberglass, because it's so much stronger. And by the way, carbon fibers are not really lighter than glass fibers, but they are much stronger, so you can use less fibers. And that's why in this panel you see there is a difference in thickness, not in the insulation, but the layers are thinner on this one. Here on the inside we have 1 millimeter, on the outside we have almost 2 millimeters. So half or 2/3 of what we use for fiberglass. And we could even go lower on the outside with keeping enough strength, but then we would not have this result, we would have a bigger impact here. So, what do we recommend to use as material for a body? Definitely sandwich compound panels. I've built my first own body from sandwich compound panels, and we still do it until today, and we never regretted it. So let me show what we are using. For the bigger vehicles where weight is not such a big issue, we use the fiberglass with the polyester matrix. It's strong enough. The weight is about 30% more than carbon, but if you have a truck that weighs 12 tons, 15 tons, 18 tons or more, the saving on the carbon is not that much. Carbon is lighter, right? But it also has disadvantages. I will come back to that later. Now, we are using 60 millimeter panels for the walls and for the roof, and we are using a 95 millimeter panel for the floor. I mean, it depends on the length and the width and so on, but it's a bit thicker because there is also a steel frame integrated to connect the body when it's assembled to the 3-point subframe, which then connects it to the chassis. Now, one big advantage of this material is that we also use fiberglass profiles to connect the walls by this type of L-shaped profiles. We glue it here, we glue it here, and then we also glue one angle, one profile on the inside, so we have a very good connection. That just gives a very strong body, and it's all fiberglass outside, it's all fiberglass inside, so we don't have any thermal stress, we don't have any corrosion, which you typically have when you make a mix of materials. We don't have a mix of material, it's all fiberglass. Another advantage of building bodies this way is that we also build the bathroom walls and other walls inside, also from fiberglass panels. They have a different total thickness, they have a different thickness of layer, but they are, again, the same material, so there is no stress with thermal things or with humidity or whatever, because it's all one material. On smaller vehicles, where weight always is an issue, we are using carbon fiber. So here we have a small 4-meter body which goes on a G 6x6. So it's not weight critical, but it's weight sensitive. And these carbon panels or walls, or here in this case it's a roof, are built in a different way. So as you can see, it's not a flat panel, but it has these edges which we are using to glue the wall and the ceiling finally together. And to maximize the weight to strength ratio, we are using here so-called pre-pregs. So a pre-preg is a carbon fiber mat, so it comes as a roll, and you have to build a mold of this size, and then you roll in the carbon fiber pre-pregs like you would do with a fabric roll, and then you put the foam on top, and then you put more layers of pre-pregs on the inside, and then in the end you put a foil and put this foil under vacuum, so the whole thing is compressed. The pre-preg actually is the carbon fiber with the matrix already in it. But as this is coming as an industrial product, they manage to use the minimum amount of matrix and the maximum amount of fiber. So you get a super high content of fiber in your layer. So you get the best ratio of weight to strength. So and then, I mean, to make it hard like this, you have to heat it in an oven or in an autoclave, and then with the temperature it becomes hard and gets stiff, and then it's like this. And so we get a super lightweight panel, which we then finally assemble when we have worked on all these other walls until windows and everything is installed. So one big disadvantage of carbon fiber is that the heat conduction is very high. So it's almost like metal. Also, if you have a body of carbon fiber, you won't have cell phone reception inside. It's like a metal cage. To interrupt the heat flow going from inside to outside, or the other way around, we interrupt here the carbon fiber, so that it's still strong enough with the bridges here, but we take this out to improve the insulation. But still, the insulation of carbon is very bad, and that's why, if you look over there, you see these window frames. Let me walk over there. So these window frames here, or the windows, and there is a window frame. They are again made of fiberglass, because fiberglass is a good insulator, while carbon is not. So we match these two polymers and these two types of fibers to get the best out of all. So, as you can see, assembling 6 panels to a box, creating a body is not really rocket science. Well, you don't only need 6 walls, you need a door, you need hatches, you need windows. And that's way more difficult. We think that there is nothing good in the market, and that's why we build all these frames and windows and hinges and everything here in-house for our vehicles. But I think that's another longer story, so let's put that in another video. So I hope you enjoyed the video today, and if you want to be informed when the next video comes, please push the bell. Thank you very much for joining.